Scalable module. Y.RIS has a scalable module function that can cascade through pin header connections. Let's start by exploring the hardware setup. To cascade Y.RIS, we need to use the pin header to interconnect them. The master Y.RIS is the rightmost unit when facing the front. The control signal and power will be passed from the master Y.RIS to the slave Y.RIS. Next, you need to connect the master Y.RIS and YTPC by DCI cable. Lastly, connect the power cable to the master Y.RIS. When the indicators on both devices light up, it means that a successful connection has been established. It's important to note that when cascading multiple Y.RIS units, the coordinate origin for parameter settings will shift to the center of the Y.RIS array. Demonstration Scenario Introduction. In this demonstration, we position the RX antenna 470 mm in front of the center of the Y.RIS array. The TX antenna is positioned on the right side at a distance of 250 mm, and 440 mm away from the center of the Y.RIS array. Both antennas are placed 10 mm above the center of the Y.RIS array. YTPC initialization. Users can configure Y.RIS using both the GUI and API. This section focuses on operating Y.RIS using API. First, it's essential to execute initialization.p as we control Y.RIS through YTPC. This ensures that the functionalities of the YTPC platform are available within the MATLAB environment. Firstly, set the MATLAB current path to the folder containing initialization.p. Copy the path and paste it into the MATLAB interface. After completing this step, you should notice that the current folder on the left-hand side is now set to the correct path. Right-click on initialization.p and select Run. After a few seconds, you should see Initial Completed displayed in the command window. Once you see this message, you can start using the YTPC platform through MATLAB. Iteration. When setting up a test environment, there may be slight inaccuracies in distance measurement due to manual measurement. To address this, we offer a program that can correct these discrepancies through an iterative algorithm. This program enables users to set up the environment without requiring highly precise measurements of the positions of the TX and RX antennas. To execute this function, open the release folder and select main test for Y.TRS iteration.m. In lines 12 to 14 of the program, you need to input the distance from the TX antenna to the center of Y.RIS. Here, in X, in Y, and in Z respectively represent the coordinates of the TX antenna with Y.RIS as the origin, measured in millimeters. Similarly, in line 17 to 19, Ri-X, Ri-Y, and Ri-Z represent the coordinates of the RX antenna with Y.RIS as the origin. Please note that a configuration of RIS panels in a 2x1 layout has been used for the current demonstration. Therefore, in lines 25 and 26, you should input the corresponding quantities of panels. If you only use a single Y.RIS, please input one for both values. In line 28, you should input the Y.RIS ID in the following order: input the slave ID first and then the master ID. After configuring the parameters, you can directly execute the program. During the process, you can observe the iterative steps of the algorithm. This process takes a bit of time. After the program finishes executing, the display at the top will show "Done," along with the total number of iterations. On the right-hand side of the screen, you will find two sets of parameters, in X, in Y, in Z, and Ri-X, Ri-Y, Ri-Z, which correspond to TX and RX respectively. You may observe a slight difference in the values of these two sets of parameters from the initially set values. This difference occurs due to the algorithmic corrections. Please ensure to note these parameters as they will be required in the next step. Parameter setting. By executing the main test for Y.RIS iteration.m program, we obtain two important sets of parameters, the corrected distances of the TX and RX antennas. At this point, the Y.RIS parameters have been set to the correct coordinates. However, we can still utilize these accurate coordinates to observe the estimated phase distribution and array factor. Next, open main test for Y.RIS.m and set the Y.RIS case to 2. In lines 18 to 20 and 23 to 25 of the program, set the TX and RX parameters according to the correct coordinates we recorded earlier. Lines 27 to 33 in the program are settings required for other cases. They represent the azimuth and elevation angles of the TX and RX antennas relative to the center of Y.RIS. However, there is no need to set these two parameters in this scenario. The parameter bits equals 1 indicates the resolution of the phase on the Y.RIS reflecting surface. The maximum allowable value for the bits parameter is 11. Next, set the number px equals 2, number py equals 1, and configure ID panel. The figure parameter allows you to switch between different modes. In this case, choose mode 3 to observe both the phase distribution and array factor. Once we configure the parameters, we will utilize 3 APIs to transmit the settings to the Y.RIS. Firstly, the first API will calculate the phase of all elements on the Y.RIS based on the previous parameter settings. The second API will transform the computed phase into the corresponding voltage distribution. Lastly, this API will set the Y.RIS LC panel voltage distribution based on the TX and RX antenna positions. After that, the Y.RIS will steer the beam toward the RX. After completing all parameter settings, execute the program. On the screen, we can now observe the array factor and phase distribution of Y.RIS. With the predicted array factor and phase distribution, we can verify the effectiveness of Y.RIS in this scenario through EVM. It can be observed that, under this configuration, the EVM achieves -25 dB. We disconnect the power supply to Y.RIS. A rapid degradation in EVM can be observed. Without power, Y.RIS cannot maintain the phase of each internal element through voltage, and consequently, it cannot reflect and focus the received signals onto the receiving antenna. Please note that after restoring power to Y.RIS, it is essential to rerun the main test for Y.TRS.m to reissue commands. Let's test if the incorrect configuration of Y.RIS parameters leads to the deterioration of EVM. Open the main test for Y.TRS.m and set the TX and RX parameters to incorrect coordinates. Then, execute the program. You can observe that the EVM performance deteriorates as well. Therefore, it is crucial to set the correct coordinates for Y.RIS to achieve optimal performance. Conclude the Y.RIS user video series. We hope you have learned how to set up the unit and mastered the essentials of its usage.